Good morning, everybody. This is Shravan, and today I would like to discuss about simple linear regression. Okay, I will take few examples and concepts. We'll cover both. So, first one, actually, I'm not giving any introduction about the data science or machine learning. I directly jump into simple linear regression. Okay, it is with one variable. So, if we wanted to understand what is a simple linear regression, it is a statistical method that allows to summarize the relationship between two continuous variables. Okay, so here we are having x and y. Okay, both are continuous. Okay, and quantitative, and we would like to find out the relation between these two. Okay, how they are related. Like if x is increasing, whether y is increasing, otherwise whether it is decreasing, if it is increasing, at what rate it is increasing. Okay, these are all actually we will be coming to know by using simple linear regression. Okay, it is a statistical method. uh, so we can solve even with the simple mathematics also, but generally if you use Python, so it solves with gradient descent any problem. Any problem actually it is going to solve with the gradient descent or some advanced algorithms. So having said that, actually I would like to tell what is x. Okay, so x, one variable denoted x, and it is recorded as, it is having three names. Either you can call it as predictor or explanatory or independent variable. Okay, I think anything actually we can call it. I use predictor. And another variable y. Okay, and this is also known as a response, outcome, or dependent variable. So generally I use target. I think another word is target, so even I use target so many times instead of a dependent variable. Okay, so this till now actually we are just discussing about the definitions. Okay, now I will go to next slide. So if we are using linear regression with one variable, okay, this is also called univariate linear regression. Okay, so it is exactly same. Okay, like whatever I have discussed. Okay, it is like I am going to predict y with respect to x. Okay, y is nothing but my target. Actually I need to predict it, and I need to see what is the pattern, what are the patterns are there between, or what is the relation is there between my x and y. Use that relation and predict the y. Okay, so this is what exactly we are going to do in our simple linear regression. It is very simple because it is having only one x and one y. So now coming back, okay, I wanted to discuss about here the equation. Okay, how the simple linear regression equation look like. Okay, it is having y I. Okay, it is equivalent to, okay, beta naught plus beta 1 xi plus errata. So here if you see this one, y is equal to mx plus c up to here, but what happens is whatever you predict, it is not same as your actual value. So this is what my prediction, but it is not same as my prediction value. This is not same as my actual value, so there is some error. Okay, always there is an error. Actually if you use this error, okay, then it is meeting the y. But generally we are not talking about the error. Actually we will be minimizing this error. Okay, generally we will be minimizing this error. So uh, henceforth from now onwards I will be using yi equivalent to beta naught plus beta 1x, and this error actually we will be minimizing it. Okay, so I have written same thing here. We need to find out beta naught and beta 1 in such a way that calic calculated yi is as close as possible to actual y. Means this is what is calculated, this should be as close as y. And if you are getting that particular condition, then what is happening is your error term, this will become as low as possible. So effectively if you make this error as low as possible, then your predictions are as close as possible to your actual values. Okay, this is entire concept actually we will be using to derive the equation, or to get beta naught and beta 1, or beta naught and beta 1. Actually we will be using this particular concept now. Okay, so I just wanted to tell the steps actually. Okay, first is actually I need to define error or cost function. Okay, this is how generally we solve our problem. Okay, first I need to define my error or cost function. then minimizing this particular cost function, okay, to find my optimum beta naught and beta 1. Okay, so this one actually we can do with classical maths, calculus, using the calculus for simple linear regression. Okay, if it is a multiple linear regression, it is a little bit complicated. We can do with maths, but even maths also it is a little bit difficult because I have to go with the first derivative and second derivative. So I don't want to do that in maths. But what I do is I will use Excel. Some built-in tools are there. Okay, I will use Excel to do this one, and subsequently we will be doing the same problem by using the Python. Okay, it is having two libraries, one is scikit-learn, another is stat models. Okay, we will see both of them. Okay, so in Excel actually we can do minimizing the error function. Okay, that is one way, and we are having few other tools also, like we can fit a line and we will come to know what is the equation. That is another way of doing it. And another one is we can use a data analysis package. Okay, there is add-on, so that add-on actually we can use and we can calculate beta naught and beta 1. So we will see everything and we will compare the result. Okay, that is what I am planning for today. Okay, so first is actually I just wanted to define my cost function. Okay, so x is predictor. Okay, and it is having n data points, means maybe 100 points or 200 points, and y, it is a target, and it is also having n data points. Now what I do is actually I will just go ahead and define my beta naught and beta 1. Okay, by defining my beta naught and beta 1, I can calculate my y hat. Y hat is nothing but whatever I have calculated. Okay, so that is what actually I'm doing here. Y hat is equal to beta naught plus beta 1x. Okay, and this y hat also having n data points. So now if I see, x is having n data points, y is having n data points, and y hat is also having n data points. Now this is my actual values. These are all my actual values, and y hat is nothing but my calculated. So there is obviously there is an error, right? So that error I'm just capturing y minus y hat. Okay, this is what is my error. But what happens is sometimes my y hat can be more than y, sometimes it can be less than y. Then what happens is, if you try to take out the error, sum of the error, okay, for all the points, for all the n points, it will lead to 0 or near to 0. So that is misleading us. So we are thinking that our prediction is good, right? Because I'm getting some of the errors, it is 0. I'm thinking that it is my prediction is good, but it is not good. It is because it is getting compensated because of the polarities. Because if I'm having positive error something around 100 and negative error something around 100, if I add these two, it will become 0. Okay, that doesn't mean that actually I do not have any error, right? So to handle this particular scenario, what we can do is we will just square it up. Okay, if I square it up, the positive will be always positive and negative will become positive. Okay, so everything is a positive. Then if I just go ahead and take the summation, okay, the yi minus y hat whole square, then this is what actual error I am having. Okay, this is quantifies the error. Okay, this quantifies the error. But what I should be doing actually, this error, sum of squared error, I need to minimize it. Okay, I need to minimize it. So that is what actually I'm writing. Cost function or error function q equivalent to sigma. Actually I need to put n is equal to 1 to n. Okay, it's fine actually. Y I minus y hat whole square. Okay, this is what the summation I will do, and I wanted to minimize it. Okay, this is our cost function. Okay, till now we have seen everything about our theory. Okay, what is the theory says? Okay, this is what the cost function we are defining it, and we will be using that. So now we will do something different. Okay, we will not be studying this theory again. Okay, we will do something different in Excel, and we will do something in uh, Python. Okay, but I think there is one more thing. Okay, how can you calculate your error? Okay, suppose, just imagine, these are all my points. Suppose if I am having a line here, okay, this is what my beta naught plus beta 1x, then you will be taking, okay, this is what the error actually at x is equal to 87 something, the value is somewhere around 90, but actual value is something like around 84. Okay, this is what actually I'm having an error, right? The same thing it goes for the remaining all. Okay, I'm predicting something like here, okay, this particular point 92, Okay, I'm predicting something like around 92. Okay, but actual value is somewhere around 84. So there is some error. So now you see, these are all like, if I take y I minus y hat. Okay, so y hat is nothing but whatever I have calculated, and y is this one. So yi minus y hat. Okay, this will be the negative, right? This is actually your yi. Okay, here somewhere, and y hat is here, and yi is this one. So if I suppose if I want to take yi minus y hat, okay, this is negative and this is also negative, but here this is positive and this is positive, this is negative, and this is almost on the line. So it goes on like few are positive side and few are negative side, right? So this is just a visual representation of how we can calculate our error. Okay, how we can calculate our error. Okay, so now I will go to solution. Okay, so from here actually it would be a little bit interesting. So I have given steps here. So totally it is having around 6 steps. So what I do is the simple linear regression explanation. Okay, I will take 2 data sets and just explain, okay, what is happening. Then I will be uh, deriving the equation using Excel, and next one is I will be deriving the equation, okay, or getting the equation or beta not beta one using the data analysis package in Excel. Okay, once again from the Excel. And another thing, in Excel itself I will be minimizing the cost function by using Excel solver package. Okay, and after that I will be going with the scikit-learn and stat. So totally it is having 6 steps. So we'll go one by one slowly, and we will try to understand what is happening here. So now what I do is I will just go for mm, so now I open Excel sheet. Okay, this is my first Excel sheet. Okay, so I'm having only 8 points here. Okay, I'm having only 8 points here. So it is a very simple example I'm starting with. So it is hours of study of the students and marks. So a person who studied 0 hours, he is getting 0 marks, and 1 hour, okay, is getting 10 marks, and 2 hours is getting 20 marks. Okay, it goes on like this. Okay, it goes on like this. Now what is my question is, actually I'm having, this is what nothing but my x or my predictor, and this is nothing but my y. Okay, it is my target. Now suppose somebody is coming and asking, okay, a student is studying around 5.5 hours. Okay, how many marks he would be getting? My means, actually I am giving one x and I wanted to predict my y. So by looking at this data, so 5 hours he is getting 50 marks and 6 hours he is getting 60 marks. So he will be getting for 5.5 around 55 marks, right? It is very simple. It is very simple. But suppose if I wanted to make this, okay, little bit logical, not logical, mathematical, okay, just little bit mathematical, then what I should be doing is, okay, I'm using Excel here. So I go for insert, okay, then I take these particular values here and go for scatter plot. Okay, I'm just going for the scatter plot. Now you see it is straight line, right? Now I just go ahead and get that straight line. Now I got this straight line. Now you see this one, okay, it is just by common sense I'm telling. But if I wanted to put this into a equation, if I wanted to put this into a equation like 5.5 hours somebody studying is getting 55 marks. Suppose it is 6.5 hours somebody is studying, they are getting 65 marks. So if I wanted to put this as a mathematical equation, and because we know it is a simple linear regression, the equation look like, okay, I will make a little bit bigger. Okay, the equation look like y is equal to mx plus c, right? Okay, this is how my equation look like. So how can I get this equation? Okay, so use here, so this will become y equivalent to 10x plus 0, right? Suppose if I am using this particular equation, so it will fulfill each and every. So if suppose if I am giving 0 here, then it is 0 marks, 1 if it is 10 marks, 5.5 55 marks, 6.5 65 marks, right? This is what actually the equation it is governing, right? So whenever I wanted to predict, actually this is what the equation. Now what I do is I will just go ahead and use help from the Excel. Okay, so Now I go here and I wanted to get trend line. Okay, then I will just go ahead for more options. Okay, and I wanted to get my equation. So the equation on the chart, okay, I'm just making it. Now you see I get y is equal to x, right? Exactly, it is the same. Okay, so now what I did is actually instead of using my common sense, okay, I'm making a mathematical model. That is what, right? I got 10x. Now what we will do is we will just go ahead and see what is happening in Python. Okay, so in Python, what is happening? I will explain step by step here. So I think few things may be little bit advanced, but it's okay. It's okay. Okay. So the first step is nothing but actually I'm importing NumPy and Matplotlib. Okay, I think Matplotlib is not required. Pandas, and from the sklearn I'm using linear regression, and from sklearn matrix I'm using mean squared error and R2 score. Okay, these two I'm using. So first is importing. So I just imported it. Next, actually, I'm reading the data. So it is there in the same data. So the file, if you see, okay. So if you see here the file, actually, I'm having one is CSV file, another one is nothing but my Excel. So now what I do is actually I will open this CSV file. So because I'm using uh, CSV file for my reading, but I think I have opened CSV file here. So this is what is the CSV file. So what I should do is I just change this to file, save as, okay, Greek campus. Okay, I just change it CSV file, it is comma separated, right? So because I'm having a lot of extra data, I don't want to use that data. I will just make it as 11. Okay, I will just make it as 11, save it. Now yeah, this is what 11. Okay, but I will be using my original data 1. Okay, so if I just go ahead and see, this is a comma separated, so this is a comma separated. So I take out all everything because this data actually I'm having, I think the data is there. So I will be using exactly the same one. So here I change this one to 1. Okay, then I'm reading my data set, and after that I'm just making the -1 means I'm just deleting last one. Okay, and that it will go to the X, and the last value means uh, marks. Okay, marks it will go to Y, and hours of study it will go to X. So now if I run this particular one, okay, then yeah, I think it has been done. So but to check, okay, I go ahead and say what is there in X. What is there in X? Okay, it is having 1 2 3 4 5. Okay, it is hours of study, and if I just go ahead and see what is there in Y, what is there in Y, so I am having 1 10 20 30. Okay, these are all marks, right? So now once we have done it, okay, now I need to go to the scikit-learn linear model and import linear regression. Okay, it is a class. Okay, then I am making an instance of this particular class. Okay, then I am fitting the data. So there are these steps here. First one is importing the linear regression. Then I am making one instance of the linear regression. Then I am passing x and y and fitting. So once I fit, okay, in the regressor I will be having my equation, right? So if I just go ahead and run this one, yeah, it went well. Now uh, I can do few things here. Okay, means the first one is I can predict. Okay, I can predict the values. Okay, so if I just go ahead and predict my y prediction, so if I just go ahead and predict my y values, means this is what the equation, it contains the equation, and once again if I'm passing x, okay, then how will be my y predictions. Okay, this is what actually I'm just doing. So I run this, but I go ahead and insert something, and I will just put y print. Okay, so now you see you are having this is 0. Okay, and it is 1 into 10 to the power of 1, it is 10. Okay, this is 20, this is 30, this is 40, this is 50, this is 60. Okay, it is e to the power of e plus means it is 10 to the power of 4. Okay, so now your predictions are almost same, right? The first one actually it is e to the power of -15, that means it is 0. So 0 10 20 30 40, my predictions are right. Okay, my predictions are very good here, and I don't want to run this particular one. Okay, I don't want to run r square right now because uh, we haven't discussed it. Okay, we haven't discussed it, so I just leave this one. Then I think once again I go to y. Okay, I just wanted to see what is y. So it is 0, 10, 20, right? So we are getting y prediction. It is exactly same as this one. So once again actually there is a y pred. So I will run once again. Yeah, I think you people can compare it. But most important one is what is my slope and what is my intercept. Okay, these two actually I need to know. Okay, what my equation is. So just see here, slope is 10 and intercept is equal to -7 into 10 to the power of -15, means this is 0, right? This is 0 and this is 10. What we got, okay, if I just go ahead and see here what we got exactly same, 10x and c is equal 0, and here also y is equal to 10x, but this is nothing but your coefficient here or slope here, and coming to the constant it is 0. So whatever we have done, okay, right now, okay, in Excel, okay, with our common sense, it is exactly similar. It is exactly similar whenever I use my Python. Okay, now what I do is actually there is one more package in Python, okay, that is stat models. So if you see here, this is the stat models. So I have imported SM, okay, stat models. Now what happens is here in the stat models by default, your C is equal to 0. Suppose if you don't want to make it as 0, then you have to add constant. Okay, that is what actually I'm adding here. So that is what actually I'm adding here. So I've just go ahead and run. Okay, this is adding the constant, and once I add the constant, then I will be putting, this is nothing but my linear regression, and I'm using the OLS. OLS is nothing but ordinary least square. I'm passing y and the transformed x, that is nothing but x underscore ln. Now if I just go ahead and run this, okay, now I just wanted to know the parameters. Okay, I think I run this, then yeah, I will. Yeah, now if you see here the parameters, it is having 1.77 into e to the power of -15, that is nothing but 0, right? This is nothing but your C, and here 1 into 10 to the power of 10, okay, that is nothing but your slope. So we got the parameters, it is same but little bit of difference, right? But it is almost equivalent to 0. It is almost equivalent to 0, and here actually we got 10. Now the same thing actually I can get it in another, that is nothing but I will be running, okay, my summary. Okay, suppose if I run the summary, then it gives a lot of things. Okay, what is your r square, adjusted r square, so many things. But where I am interested is I am interested in my constant. The constant is nothing but 1.7 into e to the power of 10 to the power of -15. It is equivalent to 0, and x coefficient is 10, right? It is same like whatever we have done in Excel, and in scikit-learn and stat model, everything is same, right? Okay, it is same. Now what I do is I go for the second exam. I just go for the second exam. So I open uh, in this one, okay, second example, I need to open Excel. Okay, this one I have to open. Okay, so yeah, see here, I take this out. Now data is little bit different. Okay, a person studied 0 hours, he got 10 marks, and 1 hour 20 marks, and 2 hours 30 marks. It goes. Suppose if a person studies for the 5.5 hours, how many marks he would be getting? So 5 hours 60 and 6 hours 70, so 5.5 hours it is 65, right? So here the logic is, okay, I will not be wasting much time here. So here the logic is I am having an equation y equivalent to 10x plus 10, right? Okay, this is what, suppose whatever the point actually I'm just replacing here, okay, with x, I will be getting the result. So if I'm replacing it 5.5, it is 50, 55 plus 10, it is 65, right? So the same thing what I did is I have used the graph, okay, it is taking these two, then I will just go ahead and take the equation. Okay, the equation is also y is equal to 10x plus 10. So it is same, right? It is same. Now we'll go back to this particular one. So only one thing what we have to do is I have used it is 2, right? Okay, instead of 1 I have used 2. So quickly we can run it. So I start here. So yeah, I think now values have been changed. Okay, now I wanted to have the prediction, but I'm not much interested in the predictions. R square also I'm not that much interested right now. I'm more interested in my slope. Okay, now you see the slope is 10 and intercept is 9.999. It is almost equivalent to 10, right? So whatever we got in Excel, okay, and whatever we got with respect to our common sense, okay, and whatever Python is giving, it is exactly same. Okay, now I think don't be underestimate Python, because Python is doing whatever we know. Okay, it is like underestimating the Python capabilities or the package capabilities. We will see the real-time example after this example. Okay, after this example. So now it is 10 and 10. Yeah, I'm fine. Now I will just go ahead and run with my stat models. Okay, now stat model, it is exactly same, and I wanted to see what are the parameters. Now you see it is 10 and 10 once again, and I wanted to run the summary and see. Okay, now if I run the summary, the constant is 10 and your x coefficient is 10, right? So this proves that, okay, yeah, whatever we are having the common sense with respect to our common sense, and whatever the packages are doing, they are exactly same. Okay, why we have to discuss all these things is we need to understand the concept whatever it is running in the Python. Okay, that is how actually I'm taking a lot of time to explain it. So now what we will do is we will go for a real-time example. Okay, the real-time example is I open, yeah, this particular file. Okay, see here. So I take this out initially. I take, otherwise at least I take this one. I need numbers there, so I take this one. Okay, now you see this is hours of study and these are the marks. Now you see 0 hours 8 marks, 1 hour 24 marks, and 2 hour 26 marks, 3 hour 45 marks. Okay, now you see you cannot make a equation using your common sense, right? You do not have any particular trend. Okay, so it is having a trend, but it is not suiting to the exact equation. That exact equation actually I cannot write by using my common sense. Okay, that is what I just wanted to tell you here. So this is the data. This is the real-time data, right? Okay, this is how your real-time data look like. So you will be confused at the time. You have to take a help from the Python or the packages. Now suppose if I say, okay, forget about these things. Okay, so it is 5 and 5. Okay, I will explain to you what is about. Suppose if I'm asking the same question, if a person who studies 5.5 hours, okay, how many marks he would be getting? Now you see, person who studied 5 hours is 68 and 6 hours is 69. So can we say it is 68.5? No, because here the difference is very less. Okay, whenever the 1 hour increase in the study, you are getting only 1 mark increase. But suppose if I try to see 4 hours to 5 hours, there is only 1 hour increase in the study, but you are getting 20 marks difference. Okay, and the same thing if I just go ahead and see 7 hours to 8 hours, okay, it is almost like around how many 17 marks difference. So we cannot make a equation using our common sense. Okay, so this is where actually we will be using our cost function or whatever. Okay, but before going there, what I do is I have used this one. Okay, means I have plotted this one by using a scatter plot. Then I went for line. Okay, means I do once again. So I delete it. Okay, now what I do is I go for insert and I wanted to get my scatter plot. Okay, then go for select data. So what I'm doing is I will select this as my X. Okay, I think there are so many things inside it, so I will be removing one by one. Okay, all the series I'm just removing it. So now if I just go ahead and select data, the first one, okay, this one, okay, edit. So x I will take as these values, and y I take as marks. I will just take y as. Now if I just go ahead and do this one, so I got the points like this. So I cannot have a straight line which is passing through all these points. Okay. Now, but what I will do is I will just go ahead and try to get my trend line. Okay, I think this is what my trend line. Then I will just go ahead and do my equation. Okay, the equation I have to plot it on this one. So equation on the chart. Now see, I got something like, yeah, I will just make a little bit bigger here. So, and I increase the size. Okay, now you people can see that, okay, equation is 9.6167x plus 11.42. Okay, this is nothing but your m or your slope, and this is nothing but your constant. Otherwise it is beta naught and it is beta 1, right? Okay, so but how this is calculated, I think it has used so many techniques to calculate it, right? But what we will do is we will calculate it by using the theory. So whatever theory we have learnt, okay, in the presentation. So I will just go ahead to the theory once again to have a good idea. Okay, so, okay, so what I should do is I need to get my y minus y hat. Okay, before that I need to calculate y hat, then get the error and go for sum of squared of error, then minimize it. Okay, so this is nothing but your cost function, right? So what I should do is I have to get my cost function, then I have to minimize it. Okay, so to do that one, first I need to have the equation and get all your y hat, then get the error, then error square and sum it. So I do the exactly same thing here. So which one is this? Yeah. Okay, so I start with some m and some c. So I think instead of that one, I say it is beta naught. Okay, so this is beta 1. Okay, and this is beta naught. Okay, so what I'm doing is beta 1 is equal to 5 and beta naught is equal to 5. Means I'm just taking randomly. If people wanted to take whatever value, people can take it. Okay, so your equation is also, it is like y equivalent to beta naught plus beta 1x. So here I'm just following a different convention, beta naught and beta 1. Actually, you people can use even y is equal to mx plus c. Okay, anything is fine. Now you see, beta 1 is equal to 5 and beta 1 is equal to 5. Okay, I have taken randomly, but if you people want, you people can take whatever. Now, once I have this one, what I should be doing, I should calculate my y hat. So how can I calculate my y hat? So I have to use beta 1. Okay, this is nothing but my slope. I will make absolute reference so that actually this can be used again and again into hours of study 0 plus y beta. Okay, this also I will make absolute reference. See, I will tell you what happens with absolute reference. Now suppose if I just drag it, okay, now if I go and see what is my equation, okay, still it is j2. J2 is nothing but your beta naught. So it is not changing. Okay, whether you are going for the first or second, it is not changing. But coming to the A3, okay, it is changing. It is A2 and here it is A3, right? So that is where actually we are using the absolute reference. So these are all nothing but my y hat. So once I get the y hat, what I should be doing? I should get yi minus y hat. That is nothing but my error. So this is nothing but my yi minus corresponding y hat. Okay, this is what my error. So I just make it, I think here all the errors are positive. Then what I should do, I have to square it. So into one second. So now I got all my errors. Then I need to sum it up, right? So what I do here, I go for sum. Okay, take all these values. So I got something like 7040. This is nothing but my sum of square. Now what I should do is, by changing beta naught and beta 1, I need to minimize it. So we can do that by using calculus, but here there is a simple tool. Okay, so if you people go here, file, okay, then options, then add-ins, okay, then actually people can find here Excel add-ins, then go. So if people have to do the solver add-in and analysis pack, okay, this we will be using later. So I just make it as yes. Okay, now if I see in my data, so I will be having the solver and data analysis both. So but right now I'm using solver. So I open the solver. In the solver, what it says is what is your objective. Okay, my objective is this one, right? This is F2. So I change it to F2. Okay, this is nothing but my objective, and I wanted to minimize it. So I will just click on minimization. Okay, by changing what values? By changing J2 and J3. So here I will just come and I will select these two, J2 and J3 by changing it. And here one important one is actually make unconstrained uh, variables non-negative. Okay, so it is non-negative values if you want. Actually people have to take here, but actually I can take whatever value, right? Whether it is a negative or positive, I don't mind. And I'm just keeping my solving method, it is same. Now what I do is I will just go ahead and run solve. Okay, it takes some time and it solves. Now you see your sum of square of error from 7040, right? Previously it was 70402, it has become 186. Okay, so this is minimized. And what are the corresponding your beta naught and beta 1? Okay, it is 9.61665, and here it is beta naught is equal to 11.422. Now if you try to compare these two, right, they are exactly same. Here it is you are getting 9.6167. I think if you round it off, it is the same thing. And the second one, it is 11.422. If you round it off, it is the same thing, right? So this we are solving by using our cost function, right? The cost function, we have derived it and we minimized it and we got beta naught and beta, right? They are exactly same. Now what I do is I go back to my Python. Okay, so simple. Okay, same code. What I should do, I have to change my file to 3 because I used marks underscore hs underscore 3. So once again I start. Oh, I think it is not required to run again, but it's fine. Okay, started. Then I'm reading the data. Then I wanted to know what is x. Okay, and I wanted to know what is y. Okay, I think y, they are different. Now I'm fitting my model. Okay, then I go for the predictions and I wanted to see the predictions. Okay, I'm not much bothered about the predictions right now, even R square also. Okay, but I'm just running it. So what is important is for me, what are all my slope and intercept? Now you see, slope is 9.61666. Okay, so if you just go ahead and see here, 9.6166, right? It is same. And if I see here once again, intercept, it is 11.422. Okay, so if I see here, it is 11.423. So it is same, right? So whatever I have done, okay, with respect to my cost function and minimizing whatever values I got it, okay, the Python, it is doing exactly same. Okay, but it is a little bit sophisticated method. It is a little bit sophisticated method, but coming to the concept wide, it is okay. The same thing what I do is I will use stat models. Okay, now stat models, the same thing, and parameters. Okay, so if I see the parameters, it is 11.42. It is constant. Okay, first it will give the constant, and after that this is nothing but your slope. Okay, and if I wanted to get the summary, okay, I think this is what the summary, right? So if I wanted to see what is the summary, now you see our constant is 11.422. It is same, and x1 is nothing but 9.667. So 616. So it is exactly same. So this is how actually we can understand, okay, what is a cost function, how can we solve it, and whether the Python packages are doing the same thing or not. So here I just wanted to tell one more thing, like if you people wanted to get good idea about your linear regression model, the better way is you people have to use a stat model because it gives a lot of things. Okay, I think R square, adjusted R square, some AAC, BAC. Actually, we are not going to discuss all these things right now, but F statistics and probability of the F statistics. And if people see here, I think here your coefficient and standard error, what is the t value, okay, and what is your p value. Okay, this p value is very important. Okay, if it is less near to 0, then your coefficient is having the significance. Otherwise it do not have any significance. If it is more than 0.05, it do not have any significance. Okay, so this will give very good visual representation, means more information also. We can get lot of information here when you compare it with the second. Now what I do is I do the same thing. Okay, means the way in which you are getting the result here, right? So we can do that in Excel also. So what I do, this is my Excel file, right? So I will just go ahead, I take this one out, otherwise it will give. Okay, I will make this a little bit small. Okay, and I will push it here. Then I take out this also. Okay, so now what I do, I go for the data analysis. Okay, so in this one we are having a function, okay, regression. So I just start regression here. So it is asking what is your y value. Okay, this is nothing but my y value. And what is your x value? Again, this is nothing but your x value. Okay, so and it by default it takes the 95% of the confidence. Okay, it is fine for me, and I wanted to put this output somewhere here. Okay, so I just keep it here. Now if I just go ahead and run it, okay, now numerical data, so labels are inside, right? I have selected even the first one also, so I have to keep labels are inside. So I will just run this one. Now you see, okay, if you see this one, your result, okay, your r square, okay, 0.98, adjusted r square 0.96. Okay, if I just go ahead and see, okay, 0.968, 963. Okay, yeah, here what did you get? Yeah, 9, yeah, it is multiple r. Okay, not this one. R square is 967 and adjusted r square is 962, means it is almost like 963, and standard error. So you will be getting exactly the similar way as your result here. So you are getting something like your r square, adjusted r square. I think few other things are there here like AAC, BAC, we cannot get it. But come to this particular portion. Okay, come to this particular portion and see here. Okay, so you are having the same thing. See your intercept and what is your standard error for that particular one, and what is the t-stat, what is the p-value, and what is the 95% upper, and what is the line 95% lower. So that is exactly same thing like whatever you get here, right? So this is the better way, stat models. And when we go for full course on machine learning or linear regression, actually there are so many other things like what is p-value, what is t-value, and what is VAF, what is multicollinearity. Okay, we can do a lot of things. Okay, this is a just brief, okay, to tell that what depth we are going to learn, okay, whenever we take this particular course. Okay, so with this one actually I'm having few more slides, but it's fine actually, means my intention is to just to tell that what is the depth I'm going to teach. Okay, I think you people may be knowing right now the depth at which I'm going to teach all the algorithms, not only this algorithm. Actually you take any of the algorithms including deep learning as well as classical machine learning. Okay, this is the depth actually I will just go and tell. Okay, so okay, thank you very much for watching this.